Welcome to Lecture 26, 4.4, Properties of Logarithms. Okay, so the first objective is to apply the product, quotient, and power properties of logarithms. So first off, the product property. Now remember, product means multiplication. Okay, so let b, x, and y be positive real numbers where b is not equal to 1. Then we have the following rule. If we have log base b of x times y, this is going to be equal to, and now we write it as a sum. So we have log base b of x plus log base b of y. So notice here, what happened was the b stays the same for both of the new logs, but the x is in one argument and the y, let me change the color, is in the other argument. So if we have originally a multiplication problem, it'll end up becoming an addition problem when you're splitting up two logarithms. One thing to note for writing out logs, your base should be sort of below the middle line for the O and the G. So your base kind of should be below, hanging out by the tail of the G. Your argument will be sort of the same area as the O and the G. And then any exponent on your argument should be up above. Okay, so just keep that in mind when you're working on your work. Notation is something that's important, and if the work starts to look sort of unrecognizable, like I'm not certain if your argument is your argument or your base, then that's where you may not get all of the points. So just make sure your handwriting is, neat and concise. All right, example 1. Write the logarithm as a sum and simplify if possible. So how do we write it as a sum? Well, if inside of the argument we see multiplication, then we can split it up as a sum. So inside log base 3 of 27y, I see we have 27 times y. Actually, let me change that from the x symbol to a multiplication dot so we don't confuse it with the actual variable x. So when I see that, I'm going to go ahead and split it up. We'll keep the base of log, so keep the base. And then we split it up with a plus sign, remember? And there we go. Now, can we simplify any of this? Well, the first one is log base 3 of 27. And remember, this is asking us 3 to what power gives us 27? And that's going to be 3. So we can simplify to 3 plus log base 3 of y, and we are done. Next, let's take a look at the next one. How many multiplications do you see inside of this? This is the natural log of e to the third power times x, times y, we have 3. Now, even though the original property does not show it for 3, we can use that property and sort of extend upon it. This will be the natural log of e to the third power plus natural log of x plus the natural log of y. Alright, so can we simplify any of these? Well, remember, what is the base of the natural log? The base of the natural log is base 3. I'll go ahead and write this out so you can see it. So that's log base e of e to the third power plus ln x. Let me change that. Wait. ln of x plus ln of y. Once again, as I mentioned before, if you use the scripted n for ln, that's fine, or if you use the capital ln, that's fine. I've seen either one used. Those are both fine. Okay, so simplifying this, the e's sort of, as you would say, cancel out. We're left with 3 plus ln x plus ln y. And there is our answer. Now, let's go ahead and take a look at the next property. So the next one is quotient, and quotient means division. So the quotient property. Well, once again, let b, x, and y be positive real numbers where b is not equal to 1. And then the quotient property is going to be as follows. If we have log base b of x divided by y this time, so notice we're using division, that is going to equal log base b of x minus log base b of y. So note, division and subtraction are connected here. Now let's take a look. So the base will remain the same, just like before. Then we have x in the top. So the top value, you're going to subtract the bottom value from it. You would never reverse it. Okay, so the top value should always be the first logarithm, and then the second value will be the second logarithm, subtracted away from it. Okay, addition, it doesn't really matter if you accidentally mixed up the addition, but with subtraction, it is important to remember which one should be subtracted. So let's take a look at example 2. If you want to pause the video and try this out by yourself, go ahead and try to do that. Alright, so I see that division, so I know the c is going to be the first argument, and the 90 will be the other argument. So this is log base 3 of c. We have a minus log base 3 of 90. Now let's see, are we done? I always like to check if we can simplify anything. Well, log base 3 of c, we can't do anything with that. But the log base 3 of 90, that is going to equal log base 3 of 9 times 10. Now, you might wonder, why did I choose 9 times 10? Well, notice we have a base 3, and that's a 9. I can go ahead and use the power rule to simplify that. So I'm going to go ahead and split that up. So we have log base 3 of c minus, and I'm going to split using the product rule. So 9 and then plus log base 3 of 10. So what did I just do? I split these guys using the product rule. And now I'll go ahead and simplify. So let's see, log base 3 of c minus. Actually, I'm going to go ahead and distribute in that minus sign real quick. So this is something very important to notice. That minus sign should be distributed to both the log base 3 of 9 and log base 3 of 10. Okay, and then I'll go ahead and simplify this to 3 and 3 to the second power. So I just turned 9 into 3 to the second power, plus log base 3 of 10. Simplifying. 3's cancel, we're just left with a 2. And we have log base 3c minus 2 plus log base 3 of 10. And there we go. Sort of a fun problem. It had a hidden product sort of hanging out there. Let's take a look at the next one. Once again, we have division, so we can simplify that. The y is going to be the first value, and then we'll subtract from it the log of 200. Can we simplify it? It's always a question. Oh, what is the base for my problem here? I don't see a number. Well, if we don't see a number, remember, what can we assume that it is? We can assume that it is a 10. So these are all log base 10s we're working with. Well, I cannot simplify the log of y, but looking at the 200, I can rewrite that as 10s. That'll be log base 2 times 100. Similar type of concept going on here. Then we have the log base 10 of 2, plus we switched from the multiplication in the argument to the addition of two different logarithms using the rule before. And I'll go ahead and change that 100 to 10 squared. Now notice, you could go ahead and add the parentheses for the argument. A lot of times I usually do like to write the parentheses in the arguments. It's normally not required unless you have a binomial or something. But I think it's often helpful to let the person who's reading your work know what the argument is. Sometimes it gets lost. Alright, so log of y minus log of 2, and I'm going to go ahead and distribute in that minus once again. And we'll get minus log of 10 squared. Now, the logs can cancel right there, and we'll be left with log of y minus log base 10 of 2 minus 2. And there we go, our answer. The next rule that we're going to look at is called the power property of logarithms. And this one is really useful when we're solving equations with logarithms. So definitely keep this one in mind. Let b, x, and y be positive real numbers where b is not equal to, and that should be a 1. So not 10. b is not equal to 1. Let p be any real number, then what do we have? Well, log base b of x to the p power, what can we do? Well, we can technically bring the p out front. This is p times log base b of x. Alright, so that is the power rule for logarithms. If you have an exponent on your argument, you can bring it out front and multiply it to your logarithm. This has to do with the fact that logarithms are tied to exponents. Let's go ahead and use that on this problem here. So the first one, we'll go ahead and bring out that 2 to the front. This will be 2 times log base 3 of 3. Ooh, and can we simplify? We can. Log base 3 of 3 simplifies into 1. So that'll be 2 times 1, which is just 2. Now the next one. Oh, that's kind of weird. There's a cube root. I don't see a power. Or do I? Remember, we can rewrite cube root into the 1/3 power. So we'll go ahead and bring that 1/3 to the front of my natural log. And I'm left with 1/3 times the natural log of x. And can we simplify anything? No, that looks like it. Okay, let's go on to something that's good, that's actually really important. So the properties of logarithms, just like we have the properties of exponents. So if you have log base b of 1, this will be equal to 0. Because that's basically saying b raised to what power gives me 1. Now log base b of b is 1. Then log base b of b to the p power, they'll simplify and we just get p. Log base b of b to the x power, once again those are a simplifying one and we get x. Now the next one we have are the 3 that we just went over. So log base b of x plus log base b of y. See if you can fill out the other 2 by yourself from memory. Alright, so hopefully you're able to fill them out from memory. And here we go. And then lastly, bringing out the power rule. There we go. Once again, we have lots of things flying around. We have exponents and bases, so make sure to keep things in the right line. So your bases should be down by the tail of the g and so on. Now, write a logarithmic expression in expanded form. So write the following logarithmic expression in expanded form. A lot of students wonder, well, how do I know if it's fully expanded? The basic rule that I like to use is something is expanded if there's no more multiplication, division, or exponents. Okay, so let's take a look at these 2. Right now, for part A, I see division. That means we need to fix that. I also see an exponent on the y. We need to fix that. And then I see 3 multiplications in the bottom. There are a lot of things that we need to fix with this problem. Okay, how about b? Do I see any of these that need to be fixed? Well, I have the radical. I know that's a power. I need to fix that. I have the multiplication. Got to expand that. And lastly, I have that square that I need to expand. So these guys are definitely not fully expanded. So we're going to go ahead and expand these using these properties. And the ones on the right, so 1 through 4, these tend to be our simplifying values. These other ones are the ones that we tend to use more for the solving of equations. So let's go ahead and expand. First off, what should we do? Usually I get rid of the large exponent if we had one, but there is no exponent fully on the outside. That 3 is just being used with the y. So there's nothing outside the whole argument. So because that, we'll go ahead and split the division. We have the top and the bottom. So that'll be log base 3 of y cubed minus log base 3 of 9 times x times y. Are we done? No, why not? Well, because I still see a power hanging out right there, and then I still see some multiplication hanging out. Still got to fix that. So we'll go ahead and bring that 3 out front. So we have log base 3 of y. How do we do that? Once again, we just brought it to the front using the power rule. Next, we'll go ahead and split this logarithm up using the product rule. Log base 3 of 9 plus log base 3 of x plus log base 3 of y. And once again, I used my parentheses because we needed to use this negative and distribute it to all 3 of them. That is another common mistake sometimes students do. They forget to use those parentheses. So make sure to plug those in. And then let's see, what do we have? That'll be log base 3 of, and I'm going to change that 9 to 3 squared. Just thinking about the base matching up right there. Then log base 3 of x plus log base 3 of y. Can we simplify anything? Well, we can simplify those 3's. Those are gone. That'll be 3 log base 3 of y plus log base 3 of x plus log base 3 of y. Can we simplify anything? Well, are there any powers that need to be distributed? Nope, none of these guys have any powers, so that's good. Any divisions or multiplications in the arguments? No, they're all good. The only thing I can think of as simplifying is that we have two different log base y's. We have 3 log base y's here plus 1 log base y there. So how many in total do we have? We have 4 log base 3 of y's plus log base 3 of x. And there we go. How is that? Hopefully not too bad. Let's take a look at the next one. If you want to go ahead and give this one a try by yourself, that'd be a good idea. So, should I start with the division first, like I did with the other one? The answer is going to be no. Why? Well, because I have that cube root around everything. So I'm going to need to get rid of that first. So let's go ahead, and I always like to change it to a power. It's a little more recognizable. So we'll go ahead and write that as the 1/3 power. So this will be the natural log of x plus y squared divided by xy to the 1/3 power. Then we'll use the power rule and bring this out to the front. So it'll be 1/3 times the natural log of, and now we have just our argument hanging out. Are we done? The answer is no. Why? Because we have a division in the argument and we still have multiplication in the argument. We need to get rid of those. Go ahead and try pause the video, see if you can simplify this by yourself, and check in with me in a sec. Alright, so hopefully you tried this out. Then let's see. Let's do the division first. We'll go ahead and split that up. Because we have that 1/3 on the outside, we need to use the parentheses. Okay, just like with the minus sign. So this will be x plus y squared minus the natural log of x times y. Can we split anything? Well, we have that multiplication going on in the last argument there with the x and the y, and then we also have that exponent 2 there. Those are two things that we need to expand on. So we have 1/3. We'll go ahead and use the power rule to bring that 2 out front of the ln. Minus, and then we'll split this. Ooh, we got to use another set of parentheses. Times x plus ln times y. Ooh, a lot going on. Let's see, what do we have here? Ooh, we have that addition going on between the x and the y. Can I split that up? Well, the answer is no. The only things we have for splitting are multiplication and division. We don't have anything with addition inside the arguments. So we cannot split up that binomial x plus y. That's just going to stay how it is. So what I'm going to do is I'll go ahead and distribute that negative into both of those. Now we get 1/3 to natural log of x plus y minus the natural log of x plus the minus the natural log of y. And then after we do the minus natural log of y, we're going to go ahead and multiply in that 1/3. It's hanging out there on the side. So we'll go ahead and bring that into all of them. And we have 2/3 natural log of x plus y minus 1/3 natural log of x minus 1/3 natural log of y. Okay, final check. Are all exponents gone from our arguments? The answer is yes. Do we have any multiplication in the arguments? No. Do we have any division in the arguments? No. Okay, our checklist is done. And we're done. We've expanded. Okay, so now we learned to go from a single logarithm to an expanded logarithm. That's just what we just did. We went from a single one to expanded, single to expanded. We're now going to do the exact opposite in the other kind of problem. This time it's writing a logarithm expression as a single logarithm. We're going to practice backtracking. Okay, so notice how all of these are nice expanded logarithms. The plan is to go the exact opposite direction. So how will we do that? Well, let's take a look at our rules that we have in the beginning. For exercise 4, or example 4, we went from this side to this side. So we expanded. We went from the condensed version to the expanded version. Now what we're going to do in the next example is we're going to go from the expanded version over to the condensed versions. So if we see any addition, we're going to turn that into multiplication. If we see any subtraction, we're going to turn that into division. And if we see any powers on the outside, we're going to go ahead and bring them back up to the top of our argument. All right, so that's what we're doing this time. We're kind of doing the exact opposite direction. All right, let's take a look. So for the first one, do we see any addition or subtraction that we need to get rid of? Yeah, for part A, I see we have subtraction here and addition here. Do we see any powers for the first one? No, we don't have any powers. But let's take a look at B. Do we see any addition or subtraction we need to get rid of? Yeah, right here and right here. I don't count the values inside the arguments, because remember, we never look inside the arguments for addition or subtraction. Do I see any powers? I do see a power. I see that 1/2 in front, so I know I'm going to need to bring that out as well. Or I need to bring that up. All right, let's get started. So for the first one, what I'm going to go ahead and do, now this differs. Some people like to work with the negatives, but I like to turn the negatives into a -1 exponent. So bear with me. I'm going to turn this into, see that minus log base 3 of 20? I'm going to turn that into plus -1 times log base 3 of 20 plus log base 3 of 20. Now I'll go ahead and, because I see that -1 being times to the logarithm, I can treat that as the power rule and bring that -1 up to the top of the 20. So that'll be log base 3 of 54 plus log base 3 of 20 to the -1 plus log base 3 of 20. Now, these are all addition. So remember, if they're all addition, the opposite direction of this will become multiplication of the arguments. So we're going to keep the log base 3, and multiply the arguments. So that'll be 54 times 20 to the -1 times 20. Now, can we simplify the arguments? Well, these two 20s, they are the same base, so we'll go ahead and add the exponents, and that'll be -1 plus 1. So they'll cancel out, and we're going to be left with log base 3 of 54. Now let's think of our checklist again. Remember, we're doing the condensed version, so we should have no addition of logarithms. We don't have that. And all exponents should be put back up. Well, this fits that description, so we'll go ahead and box this off. This is our answer. You could technically simplify the 54 with the 3 by turning that into a 27 times 2, but then you would end up with two separate items, and it wouldn't be one logarithm anymore, and we just want one logarithm. So we're going to go ahead and stay with it right where we are. Now let's take a look at the next problem. Go ahead and give this one a try and check back in with me in a second. Alright, so first, I always like to get rid of the exponents if possible. So this first natural log has an exponent and the other ones don't. But as usual, I always like to get rid of the negative as an exponent. You don't have to do that. Some teachers prefer other methods. Just let me go ahead and set this up so we can look at that other one as an exponent. So plus the -1 times the natural log of m plus 1. Then I'll go ahead and move the exponents up. And we get natural log of m to the 1/2 power plus natural log of m squared minus 1 plus the natural log of m plus 1 to the -1 power. So now we have all addition going on. That makes it very simple. We'll go ahead, keep the natural log, and multiply the exponents. So m to the 1/2 times m squared minus 1 times m plus 1 to the -1. I'll go ahead and color code this so you see where everything's coming from. Then we got that going on there. And let's see, and the natural log that we're using. The natural log, we keep the natural log and then multiply the arguments together. Now, let's see. Last thing to do is just to make sure that we can simplify the argument inside as much as possible. So, well, we have that -1 exponent, so we're going to have to fix that. We're going to have to bring that down to the denominator. All right, so let's go ahead and do that. All right, so then we have the natural log of m to the 1/2 power times m squared minus 1 divided by m plus 1. There we go. My Apple Pen died for a moment, so I'm writing with my finger, which is why it kind of does not look quite as good. So we're going to go ahead and see, can we simplify anything else? Well, that m squared minus 1 looks like the difference of two squares. So we'll go ahead and factor that as the difference of two squares. M minus 1 times m plus 1, and what do you know? We have an m plus 1 in the numerator and the denominator, which means they can cancel out. We'll go ahead and cancel them. And then whatever's left over, we have natural log of m to the 1/2 power times m minus 1. Now, how do we know if we're done or not? Well, we're done if we don't have any exponents on the whole argument, and if we don't have any addition or subtraction of logarithms. And it looks like we're good. You might wonder, well, what about that half on the m? Well, remember, that's not being applied to the whole argument. That's just being applied to the m. So we're good. Now let's take a look at the, I believe, last example for this problem. So given that log base b of 2 equals 0.356 and log base b of 3 equals 0.565, approximate the value of log base b of 36. All right. So we have log base b of 36. Go ahead and write this down. So log base b of 36. Now I'm only given log base b of 2 and log base b of 3. I don't have any other values, so I'm going to really work hard to turn this 36 into 2's and 3's, because then I know the approximate values for them. If I turn the 36 into something like 9 times 4, that would not be that useful to me. But let's see, log base b of 36. Well, you know, as I said, it was a 4 times 9, but that's still not useful to me, right? Because I have log base b of 2 given and log base b of 3 given. Ooh, but I know I can change 4 and 9 into 2 and 3. So this will be log base b of 2 squared times 3 squared. Hey, what do you know? I have the 2 and 3's going on. Then I'll go ahead and use the quotient rule and split this. So log base b of 2 to the 2nd power plus log base b of 3 squared. Once again, sorry for the handwriting, using my finger. Then I'm going to go ahead and bring those exponents out front using the power rule. So this will be log base b of 2 plus 2 log base b of 3. Now at this point, I have the log base b of 2. I finally have it in my problem. Look, that's what we were given. And then I finally have the log base b of 3 in the problem. So I'll go ahead and swap those out with the values that they were given, or that we were given. So for log base b of 2, I was given 0.356, and that's all being multiplied by 2. And then I'll swap out that log base b of 3 with the value they gave me, which is 0.565. And once again, that was also being multiplied by 2. Let's go ahead and continue up here. So multiplying that out, we'll get, our answer is approximately 1.842. And we are done. So one thing to note, this was the only answer in our entire worksheet here that was actually given in a decimal. Everything else was still natural log and log. So on your exam, unless you're told to answer as a decimal, keep your answer in log or natural log form. It should be simplified, but it should still be in the natural log form. Don't plug in the log in your calculator and get an approximated decimal, unless you're told to do so. All right, that is it for this section. Please email me if you have any questions.